Exercise 10.1 question number 4. The question is, if sin alpha is equal to 4 divided by 5, sin beta is equal to 12 divided by 13, both alpha and beta are measures of the first quadrant angles, then find sin of alpha plus beta. The first part is this one, and the second part is cos alpha plus beta, and the third is tangent alpha plus beta. First we have to calculate this is sin alpha. Since sin alpha is equal to 4 divided by 5 is consider that 4 is equal to y and 5 is equal to r. Y will be perpendicular and r is the hypotenuse according to the definition of sine function. First we have to calculate the base. So compare these two equations. We have y is equal to 4 and r is equal to 5, where y is perpendicular and r is the hypotenuse. By Pythagorean theorem, we have r square is equal to x square plus y square. Y is the perpendicular, x will be the base with respect to alpha. Substitute the value of y and r. We have 5 whole square is equal to x square plus 4 whole square. 25 minus 16 is equal to x square, or x is equal to 9, or taking the square root we have x is equal to plus or minus 3. So with respect to alpha we calculate x which is equal to plus 3 or minus 3. Now the angle alpha is in first quadrant, so x will be equal to plus 3. Now we can easily calculate cos of alpha. So cos alpha is equal to base divided by hypotenuse with respect to alpha. With respect to alpha, base is x and hypotenuse is r. With respect to alpha, r is the hypotenuse. Substitute the value of x and r. X is equal to 3 and r is equal to 5. Now tangent of alpha is equal to perpendicular divided by base. Tangent of any angle is equal to perpendicular divided by base. With respect to alpha, perpendicular is y and base is x. Y is equal to 4 and x is equal to 3. Now sin of beta is equal to 12 divided by 13. Further to calculate with the other remaining quantity from this data, which is sin beta is equal to 12 divided by 13. 12 sin with respect to the function sin y1 divided by r1. y1 will be perpendicular and r1 will be the hypotenuse. Compare these this equation. We have y1 will be equal to 12 and x1 will be equal to 13. y1 will be perpendicular and r1 will be the hypotenuse. To calculate x1 with respect to beta is the base. With respect to beta, x1 is the base. So again we apply the Pythagorean theorem to calculate the base with respect to beta. So from the Pythagorean theorem, r1 whole square is equal to x1 whole square plus y1 whole square. Substitute the value of r1 which is equal to 13 whole square is equal to x1 whole square plus y1 is 12 whole square. After the simplification we get x1 whole square is equal to 25, x1 is equal to plus or minus 5. Since beta is in first quadrant, therefore x1 is equal to plus 5. Now with respect to beta, cos of beta is equal to base divided by hypotenuse. With respect to beta, x1 is the base and r1 is the hypotenuse. Substitute the value of x1 and r1. We have cos of beta is equal to 5 divided by 13. So the value of cos beta is 5 divided by 13. To calculate tangent of beta is equal to perpendicular divided by base. With respect to beta, perpendicular is y1 and with respect to beta, the base is x1. Substitute the value of y1 and x1. We have 12 divided by 5. Now to calculate cos of alpha plus beta, we have cos alpha cos beta minus sin alpha sin of beta. The second part of this question is this one. So cos alpha plus beta is cos alpha is equal to 3 divided by 5 and cos beta is equal to 5 divided by 13 minus sin alpha is equal to 4 divided by 5 and sin beta is equal to 12 divided by 13. After the simplification, we get 15 divided by 65 minus 48 divided by 65, and after the simplification, we get cos of alpha plus beta is equal to minus 33 divided by 65. The first part of this question is sin of alpha plus beta is equal to sin alpha cos beta plus cos alpha sin beta. To calculate sin alpha plus beta, we expand this identity. So sin alpha plus beta is equal to sin alpha is equal to 4 divided by 5, cos beta is equal to 5 divided by 13 plus cos alpha is equal to 3 divided by 5 and sin beta is equal to 12 divided by 13. And after the simplification, we have sin alpha plus beta is equal to 56 divided by 65. The third part of this question is tangent alpha plus beta is equal to tangent alpha plus tangent beta is a whole divided by 1 minus tangent alpha tangent beta. So tangent alpha plus beta is equal to substitute the value of tangent alpha, which is equal to 4 divided by 3 plus tangent of beta is equal to 12 divided by 5 is a whole divided by 1 minus 4 divided by 3 multiplied by 12 divided by 5, and after the simplification we get tangent alpha plus beta is equal to minus 56 divided by 33.